Okay, let's go ahead. I didn't start the video yet. All right. So we put these two equations in. What's going on? I'm sorry.
Nothing. We were just talking about it.
Okay, so if you're not gonna put these in, I'm just gonna ask you guys to be quiet. All right. So you got -2,
What's that?
and that's it. Then we don't. Once we get this done, everything will go pretty quick. 3x to the 5th. And -2x.
How do you get it to squared?
What's that?
Because like it does this.
Oh, I got this wrong.
Oh my god.
Like how do you get it to squared on the computer, Mr.
And you do shift 6.
Shift 6.
Shifts?
On the calculator, on the computer, yeah.
Got it.
And then I have one more. It's x to the 7 plus 7x squared.
What do you think we should make our window on the calculator, Mr.
On this one, I think you can just keep it 10 standard window.
I'll change it.
Okay, so I got x to the 7th plus 7x squared. All right, plus 7x squared. Okay, so I'm gonna give it to them. Okay, x squared. Okay, so looking all pretty weird there, but anyway, I wish I could do again. Is I'm not sure why I can't. Oh, there it is. So anyway, so what I want you to notice is if I can stretch this out a little bit. Oh, I did. Finally could. All right. Now, what I want you to notice is that is what we call the end behavior. One of the things that I told you is that we have certain. Put the phone away, guys. Put the phones away. All right. One of the things that we will notice is this is the just look. This is the x-axis and this is the y-axis. For every one of these odd functions, we'll notice about where the function comes from and where it ends up going to. You'll notice that all these functions start in the lower left. This is called end behavior. End behavior is where none of the wiggling is going on. All right? So everything is down here inside this sector, right? So what happens with all odd functions? All odd functions have this type of an end behavior. Their end behavior to the left is down and to the left. The end behavior to the right is what? Notice each one of these is going up into the right. So no matter what function you have, if it's odd, like these are, the odd number that can't be divided by 2, then we end up with the same end behavior. For me, the helpful thing is the line. It's easy to remember this line. This is y equals x, which is our parent function for a line. Notice, so it's the most basic odd function. Where does it start? What's its end behavior?
Infinite.
Yeah.
I have a question.
Don't get ahead of me.
I know how to do it. I was wondering, you said all odd functions have no end behavior in the lower left?
They do have end behavior.
They do. Okay.
Right. So their end behavior is lower left, upper right. And that's for all odd functions, including x to the 2,971. All right? No matter how big that exponent is, if it is odd, the end behavior will be down to the left, up to the right. Okay, so now what I want to do is the following. I want to see what happens. So we need to commit that to memory. When you walk in and do the test, you need to remember that. How do I remember lower left, upper right? Is to try to remember, what did I do? What did I say my secret was? Was just remembering the y equals x graph, right? The y equals x parent function is an odd function. And what it does, lower left, upper right, so do all the other functions too. Okay?
Great.
So unfortunately, you have to remember that part of it. Now what I want you to do is, so, again, in review, what you need to be able to hold on to. Odd functions start where?
Bottom left.
What are their, what's their end behaviors?
Bottom
Lower left, upper,
Right.
upper right. Good. Now, what I'd like you to do is put a negative sign in front of all these functions. Okay? So, it's not a lot of work. Just all you have to do is just get your cursor. Ooh, what's going on here?
Are you recording that?
I'm not getting it in there. It's all these.
Okay, wait, I just have a quick question. So when you said odd numbers go down to the left, upper right, can it be switched like if it's negative?
Say it again.
Is it switched when it's negative?
Is that what you're noticing?
Well, I'm just wondering, because I see, is it the odd?
Well, that's what I just asked you guys to do is put a negative in front of all the lead terms.
Yeah, I didn't do it on the calculator.
Okay, so now that I did it to all the lead terms, what are you guys noticing about the end behaviors now?
They're all going to be
So seven.
All the end behaviors are
Negative.
upper left, lower right.
So
Okay.
it's negative.
So
Negative odd.
so they switch. And they switch only when the lead term is the one associated with the highest exponent. When the lead term is negative, it flips the end behaviors. Okay? So the end behaviors flip. Okay, all right.
Wait, it-
Mine
what's
is
the
different
odd
from yours.
one?
2, like for the second one, mine's just like face this way.
Oh, you got you did an x squared in there somewhere.
Wait,
Oh, is it? Oh, wait. Is it? Oh, so it's better. My bad.
All right. So anyway, so the key is again is to recognize when we have the positive when we have the lead term is positive for all odd functions, lower left to upper right. When we make it opposite, when we make the sign change, we flip that, right? Okay, now the only other kind of function we have is a thing called an even function. What I'm going to ask you to do is go to the lead terms in all these and add 1 to the exponent. Okay, so over here, for instance, I'm going to ask you to make it squared. All right? And instead of a 3, make it a 4. Correct.
What do we make?
Make it a 4. Add 1 to each lead exponent. Instead of a 5, I'm going to make that a 6. Instead of a 7, I'm going to make that an 8. And I guess I wouldn't mind taking away the negatives for the moment. So just dealing with the positive. Megan, please. Okay. What do they look like? They're all very, and that's because they're, in a sense, they're in the parabola family, right? Even exponent functions. Any even exponent function will have end behavior that's either both up or both down. What do you think's what do we do to make them go down?
Negative sign.
Negative sign. All right? So, and this is all including x to the 100. All right? We'll also have that now there's a lot of, each of the functions have little wiggly things that can happen in between. All right? But the end behaviors themselves will always be both up or both down. Yes?
For the all even functions, is there like a set for like how for odd it was all have end behavior in the lower left and upper right? Is that like the same thing for even, or is it opposite?
Okay, well, these are the even functions here.
So is
Okay.
means going up?
So I'm saying that all even functions either both go up. Do you see? We go upper left, upper right. right? So all the even functions will do this. And that's because you see how I changed that to 2, 4, 6, and 8?
But what if one goes up and one goes down? That's different.
It has to be an odd function. All right? So, and if, and we can go ahead and do the one last thing here is I can put the minus sign in front of them, and hopefully you'll notice what happens. So anytime that we have an even function, we should be seeing both up, both down, right? And both, in this case, both down means that it's a negative even function. So here, ready? So both up, it's an even positive function, right? Even with a positive lead term. Both down.
Even odd.
One down, one
This
up.
is positive odd.
Which one is it?
Positive odd.
This is not positive.
It's negative odd.
This is negative.
It's both.
It's odd, positive, right?
We just,
I heard like 100 different people
We
yelling
said
at
that.
it. Okay, so this is a positive odd. What's this one?
Negative odd.
Negative odd. Ready?
positive
Positive
odd.
odd.
Positive even.
Lower.
Negative.
Negative.
What's the
Positive odd. Negative odd. Positive odd.
Positive
odd.
Negative. Positive.
Negative even.
Okay.
Negative even.
All right, very good. So here's the test. Ready? What's that? I just
I feel bad for people that are like only listening to this because they have no idea what just happened.
is that right?
Now I understand it though. Not gonna lie. Finally understand.
You understand it now?
Yeah. This needs to be explained.
Okay.
And I'm good.
So anyway, let me. I think I lost my. All right. I'm trying to just get rid of this thing. Okay.
Overnight. The overnight. I look at it.
Okay, I am trying to get rid of this thing.
Just get the eraser.
I don't. There, I think I've got both of them in here. That's the thing.
See the eraser thing?
Oh, maybe this is.
Try that.
You think so?
Maybe, yeah.
Oh my God, that thing's got so small. All right. I'm just trying to get rid of this thing.
Yeah, use the eraser. That might work.
Oh, there it is. I'll get rid of it. Bang. There it is. Okay. All right. So, whoa. How do I delete that though?
That's what I was here, Mr. Shy.
Okay. Well, anyway.
Oh, Mr. Shy.
Okay, we try this again.
Whoa, damn.
Oh no, this is my favorite one.
Oh. That's the one I want to get rid of, right?
Oh my god, I have so much.
You have so much work. Undo. Okay, guys, tell me how to get rid of this one. Undo hide object. That's what I don't want to do.
Hit the trash can.
Wait, are you trying to get rid of it?
Yeah, hit the trash
Trying to get this one. Yeah, I'm trying to get rid of the front one.
Right there, trash can.
I know, but it's not selected yet. There. Okay, got it. All right. So, take a look. Sorry. All right. So what I want to do is, if you look at the first page, I want you to go ahead and what I want you to do is figure out which of these are. Oh my goodness, there's so many layers going on here. All right. So anyway, choose. Tell me on each one of these graphs of these 6 and the ones on the next page.
Mr. Shadiger?
Yes.
I don't know what C would be.
Even
There's a
positive.
little. Okay. I was thinking that.
Okay. And why is it even positive? Can you figure that out?
No, I just didn't know because there was like a little, like, it goes up and down kind of.
So, did you guys finish this? Oh, please put that away. And let me take that phone for you. Let me have it. Let me have it.
No,
Let me have
no,
it.
no.
Let me have it. Let me have it. Please. No, don't. No, please. Give me the phone.
Mr. Ty.
Give me the phone, or I'm going to report you to Mr. Purcell.
Fine,
I'm done with
report
the
me to Mr.
phone.
Purcell. Report me
What's
to Mr.
that?
Purcell. Report me to Mr. Purcell.
Give me the phone.
Report me to Mr. Purcell.
No, I'm just going to take 10 points off your next test. That's probably a little bit more powerful. Okay, guys, keep your phones away. All right. Do you have the answers to that?
I'm in the middle.
That's the problem. All right. Okay, ready? You got them? First one is odd, negative. Next one, B.
Even negative,
Good. Next,
even positive,
next,
odd positive,
odd, definitely odd, but it's negative, right? See, it's going, instead of going down left to upper right, it's flipped. See, you see how A is positive?
well, what's A?
A is positive, sorry.
Yeah, okay.
Yeah, I was
I was like,
Okay, sorry, now you got it. Now the next one's gonna be
odd positive,
odd positive, and then the next one is gonna be even positive. All right, is everyone good with that?
Yeah.
All right, go to the next. I want you to write either even, odd, even positive, even negative. Odd, positive, odd, negative. So see if you can't do that for all these graphs that I've like cut and pasted out of the book. So, you know, let's go real quick and just do the even odd thing. On the first one, upper left, what's that going to be?
Even negative.
Even negative, right? Next one.
Odd positive.
Next.
Even negative.
It's even again, right? And it's going down.
Odd negative.
How about and how about this one here?
she's salty, it's just,
She's sulking.
Even
I'm not answering the question.
Oh, I'm sorry. I should have warned you by asking everyone to put their phones away so I wouldn't see them. Oh wait, I did that. Okay, next.
Even positive.
Even positive. And
odd negative.
odd negative.
Mr. Shah.
Yeah.
Odd,
Yes, rest well.
yeah, you go.
Odd,
odd negative.
Neg.
You get even positive.
and then even positive. Good. So you guys got that down?
Wait, why is the one like that one even negative?
Because it's opening down. Remember, even has two. The end behaviors are either both up or both down.
Oh, so it's not going to.
Well, think of a parabola.
Okay.
Right? Okay. So, I mean, I think that the basic thing is if you think of the line, the parent function of the line, and the parent function of the parabola as examples of odd and even functions, then everything else makes sense. All right? You can base it on that. Let's go to stealth zoom. Okay. Right now, before we get to the next piece, I've got, it's 45. I got till 40, right? Okay. So anyway, right. Okay. So I want to review some notation. That's what that says up there. Some of the notation that we used in I'm going to start with this thing, what I call between notation. If you remember what that was, it was a small number in the front, less than sign, x, less than sign, 5. We could interpret this as meaning what? X is between, right. X is between -2 and 5. So, yes.
So when you're doing these, do you need to find like a specific number, or just like it could be anywhere in
Yeah, it's going to be on a number line. On a number line, that means from -2 to 5, everything in between. All right?
The rest.
So any possible number in between. Okay? And so it's notation that you've seen in the homework, but if you can use human words instead of looking at the notation, I think it makes more sense, right? The other thing that was in the reading that was somewhat confusing is just this: when f of x is greater than 0. F of x is the y value. When f of x is greater than 0, basically what that means is above the x-axis. All right? Above x-axis. Do you guys remember these words from the homework? It looked really confusing, but I think if you can translate into more human terms, you're going to be okay. F of x is less than 0. What does that mean? Below x-axis. So these are the only things that I feel would produce some confusion for you. All right? So let's go. Why don't you close that?
Oh, sorry.
All right. So to get into to be able to do some of the questions that were really confusing, we need to just be able to understand what it means for a function to be increasing or decreasing. Decreasing means it's leaning left. All right. So if I look at this function number 33, it's leaning left. So it's this area here is where it is decreasing. I don't want to write it there, actually.
So then
And where is it increasing?
when x is greater than 5 and
Wh-
less than 3.
It's going to be increasing here, right? So increasing means where it's decreasing means it's leaning to the left or and it's going down. I don't need that arrow there. I shouldn't have that. Increasing means it's going upward. Okay, so let's go ahead and we're gonna denote where this thing is increasing, where it's decreasing, and then we're gonna see when is it above the x-axis or below the x-axis. So, and if we can understand this, we can understand. Geez, Ange. Oh, it is my phone. God, I thought it was yours. What did I do with yours? Well, somebody will find it. Anyway, increasing. Where is it increasing? Probably the easiest way to say that where it's increasing is looking at this dot here. It increases for any numbers bigger than what?
5.
I think it's 4.
Oh, wait, no, numbers.
So it's increasing for x greater than 4, sorry. And where's it decreasing? When x is less than 4, it's decreasing.
I thought it was 5.
All right, that's the simplest way. Some people were trying to do interval notation and from x to infinity or something. Those are correct answers, but in this case, this is the most simple. That for all numbers less than 4, it's going down, right? It's left leaning, negative slope, and for all numbers greater than 4, it's upper right leaning, which is positive. Okay? So, and where is this graph negative? It's negative starting from this dot here at 3 and going to the left. What does that mean?
X is greater than 3.
All right.
And less than 4.
X is greater than 3. Oh, no, I'm sorry, less than 3.
Oh,
It's positive for x being less than 3,
oh yeah.
right?
I thought you were talking about negative.
X is less than 3, and it's also positive for any numbers bigger than 5. Did you get that? Where is it negative? Under the x-axis.
Well, after the 3.
Between the 3 and the 5. Well, how do we write between 3 and 5?
4. Like, oh, okay.
When
3
3 is
less than
X,
x less than
5.
5. Okay? So we get that?
Maybe we should do another.
Maybe we could do another. Let's go down to 35. 35 is probably the worst one on the page.
34.
So 35. We just did 34. Did we not?
Go to 33.
We just did 33. No, let's do 35. Okay? So there's really, like, in terms of critical points, you know, where it touches the x-axis. So the question is, where is it increasing? Increase means, where is it leaning right?
Isn't there 2 places greater than 3?
When X
There's
is
2
greater-
places, right?
Yeah.
Yeah. When X is greater than -1 and X is greater than 2.
So it's increasing for x is less than
1.
0.
Oh.
Look at it, right?
Yeah.
From here to infinity, right? So it increases until we get to the y-axis, which is 0. So it's going to say, for values of x less than 0, it's increasing.
All right.
All right? Where else is it increasing?
2.
For values of x greater than 2. Where is it decreasing?
Values less
When
than 0.
When X is
Right?
greater than 0 but less than 2.
Greater than 0 and less than 2. So how do we write that?
Like the minute.
0,
0.
smaller than X, so on and so
Did you see that?
Oh, why isn't it the other way? Like the, oh, maybe that's greater.
It's always a small number first.
No,
less
aren't
than,
those
less.
greater than or less than signs?
This just use the less than x less than. Less than x less than means between, all right?
Okay.
Okay, positive means where is it above the x-axis? Well, it's above the x-axis between -1 and 2. Between -1 and 2. How do I write that, Ange? Between -1 and 2.
It'd be -1 is less than x, which is less than the last number you said.
2.
Yeah.
Can you see it up there? All right, and where else? Okay, and where else is it positive? It's going to be for values of x greater than 2 also, right?
No, we make an ASMR video.
Okay, now where's it negative? It's only negative in one place,
on. It's less than
Less than.
-2. Okay,
I have a question.
yeah.
Couldn't you just say the positive one is just greater than -1?
You could, and the reason it's not is because what's going on is we didn't do greater than or equal to. But
No, I did not.
I feel that you
I did not. Okay.
could say that. The only problem is we're not including the place where it hit. At 2, it's touching the x-axis, so it's equal to it. So we'd have to write,
If it was -1, then it would be because it only have 1 point.
it would have to be, it'd be,
So if it has 2 points, then you need to include the 2 points in the column.
yeah, to be above the x-axis, it has to be higher than 0. So we don't include the 2 on that. I know
Yeah, it's a mile.
I don't think it's as huge an issue as it seems, but okay. And then all right, the last thing, I'd probably have you do 34, except I only have like a couple minutes to get to the last piece.
You, Mr. Shy.
So what we're doing here, interpreting the graphs and finding where they're increasing and decreasing, we do the opposite on those 2 pieces. So do your best on those.
When do you bring this up?
Yeah, do you have extra help today?
Now that the class is left, I do want to finish the packet by going to the last page. Oh, actually, before I go to the last page, why don't you take a moment, those of you who are listening to this, and see if you can't practice by doing number 34 and 36. And then, so in a moment, you should just pause this tape and complete those 2. And once you start the tape back up, once you start the video back up, you will see the answers and you can check them with your work. So I'm pausing now. Okay, you can check your answers now. You can pause for a moment and see if you agree with my answers. And once you're satisfied, we can move on to the next page. In this page, what we're going to be doing is graphing, doing the reverse of what we just did. So you're going to be given some information about where the graph is increasing and decreasing and where it exists above and below the x-axis. So for the first part of this, it looks like I already started this in another class. Let me just erase it. So for the first part, let me see if I can make this a little bigger. Okay, so it's telling us first that we have that the function is going up or up to the right between for values of x that are less than -1. So here's -1 here. Oops, forgot what the hell that stuff's about. Here's -1, and I choose a different color here. And so all the way so any numbers less than -1, we have an increasing graph, which means that it is going upward to -1. And then once it reaches -1, okay, oh, then we also have, it's also increasing for values greater than 1. So up here again. So it must be decreasing between -1 and +1. So these are just telling us that the graph is going up and down and then back up again at those places. So the next piece of information that they're going to give us is when is this function below the x-axis and when is it above the x-axis. This is telling us when it is above. X-axis. So that's between -1.5 and 0, which is a very, very small portion of the graph. I feel like I need to get a really small point here. Is it letting me choose? I don't know. So from here, okay, let me do that again. It's going to be -1.5 to 0. So -1.5, and it's right here, and it's going to go up, maybe steeply, I don't know, and then back down to 0. So during this range, it is above the x-axis. And then it says that we're also above the x-axis any number bigger than +1.5. So +1.5 it's going, oops, sorry. So at this point, it's going to be going upward. Then it says below the x-axis, right here, below the x-axis, it is below the x-axis when x is less than -1.5. So it's going to be going down this way. And also between 0 and 1.5. So from here to here. So the full graph looks like a cubic equation with a height with a high bump, a valley, and then going off to the right. So this looks like a, not that we need to know this, but it's definitely odd, and it's definitely positive. Okay, let's try the next one. Not an easy one at all.